Okay, number 5, find the area of the region enclosed by these graphs over here. I'm going to do the whiteboard and see if I can do it. All right, so let's go to the whiteboard. Whiteboard now. And I think you probably know by now what I'm going to do is try to visualize what these are. All right, so number 5, and the first thing I got is y equals. I'm sorry, it's not y equals, is it? You could rewrite these if you want, though. Anyway, I'm going to say x equals, let's see, y cubed minus 18y. And the other one is going to be y plus 2x equals 0. Well, you know what? I think I'm going to go back to doing what we did in a prior problem. It might look different than the key, by the way, but it should flow the same. So what I'm going to do is I'm going to change the x and the y around. So I'm going to say y equals, this will be x cubed minus 18x. All right? I'm going to cross this out over here. What are we going to do over here? This is going to be x plus 2y is equal to 0. So I'm going to just rewrite these like I would normally see them in a pre-calculus class. What do you get over here? You'd get y equals, well, I take x from both sides, you get minus x and divide by 2, so minus 1/2 of an x. All right? Let me cross this stuff out. Kind of done with it. Now, certainly this is changing the nature of the problem, but it's still going to be the same problem, by the way. All I did was I rotated, all right? X became y and y became x. Right. The next thing I would do is I would make some attempt to visualize the problem. And to do that, I want to go back to what I learned in pre-calculus. So this is going to be y equals, I factor an x out. You get x squared minus 18. That's not so bad. Here you get y equals x. I'm going to write this as x plus root 18 and x minus root 18. I'm not too worried about those numbers, by the way. This is just y equals minus 1/2, right? Not a big issue. All right, so what I'm going to do over here is, kind of draw the picture. Of this guy. So I'm going to say I got a 0 there. That's easy. I get a 0 at root 18. That's over here somewhere. By the way, root 18, if you're thinking about it, it's going to be between 4 and 5. But I'm not putting numbers down. In fact, I'll say this is root 18 over here. I also see minus root 18 over here. All right, what do I got? I got a cubic problem, and I'm going to say I know it's got a sort of a look like this over here. All right, let me just be careful about this. All right. Okay. Here comes my problem, by the way. Point of intersection. All right, I know there's one. I know this line over here is, minus 1/2 of an x. So I know the line's going through like this over here. I know that. But what I'm not sure about is where is it hitting? So what I want to do is I want to go through that with you. And that might be tough to do, but I can write this down. So when does x cubed minus 18x equal, well, it's got to equal minus 1/2 of an x, right? Let's just go through that. And I'm going to, I'm going to multiply both sides by 2. So you get 2x cubed minus 36x equals, that's going to be what? If I multiply by 2, that's going to be minus 2x. Not 2, I'm sorry, I made a mistake there. That's going to be minus x. All right, let me see what I've done so far. So I got 2x cubed minus 36x minus x. Let's keep going. 2x cubed minus 35x equals 0. I'm going to factor that, pull out an x, and what do you get? You're going to get 2x squared minus 35 equals 0. Well, as expected, I certainly get a 0 there. What's this point going to be? 0, 0. Let's talk about the other points, though. And what are they going to be when 2x squared minus 35 equals 0? So what do you get there? 2x squared equals 35. And then we're going to divide both sides by 2. You get 35 over 2. And then x would equal the square root of 35 over 2. I'm going to simplify a little bit. This is going to be root 70 over 2. How'd I do that? Multiply top and bottom by 2. So I got 2 points over here. And I'll put this down for you, something like this over here. Again, I'm not saying it's terribly accurate, but I will say this, though. There is symmetry over here. And although it's hard to look at this, I'm going to say that these are equal regions over here. All right, equal regions. All right, if I compute one, I know the other. There's symmetry over here. How do I know that? One thing is I notice the knot function. I know that much. Okay? So what do I do over here? I'm going to talk about, I kind of want to just write down one integration, but I'm going to double it now. All right, and the reason for that, if I know one of these guys, all I got to do is double it to get the entire area. All right, we'll look at the key later. So I'm going to say it's going to be, whatever this area is, it's 2 times something. Now, which one am I going to choose? I'm going to choose this one here. Now, where does it start? Oh, I got it right over here. Root 70 over 2 minus, by the way, I forgot to put plus or minus here. Sorry about that. Okay? And where does it stop at 0? What's the upper curve? It's that cubic problem, right? Oh, by the way, the differential here is dx. What's the upper curve? X cubed minus 18x minus, what's the lower curve? Minus 1/2 of an x. All right? Oh, I'm sorry. It's minus a minus a plus. All right? We're looking at this, upper minus lower. I'm going to take the 2 on the inside now. And what do you get over there? You're going to get minus root 70 over 2 to 0. 2x cubed minus 36x. I'm distributing by 2, by the way, plus x dx. Let's keep moving. Let's see, 2x cubed. I'm simplifying the integral, by the way, minus 35x. Boy, that's deja vu all over again, isn't it? Let's keep moving. And what do you get over here? Antiderivative. So what are you going to get? x4 divided by 4. You have a 2 on top, you get 2 on the bottom. Not so bad. What do you get over here? Minus 35 x squared over 2. Limits integration minus root 70 over 2 up to 0. Well, it's not that bad to evaluate, but again, you may say to yourself, I'm sick and tired of doing arithmetic. Let me use my calculator. On exams, you don't have a calculator, but the upper limit would be 0 minus 0, which is 0. Minus, let's do the lower limit. And yes, it is more difficult. I'm going to pull out a half, though, to help me with the arithmetic. What are you going to get? This number here is going to be raised to the 4th power. And I want to point out what that means to me. When I'm squaring that number, I would get 70 quarters. But I'm raising it to the 4th power, so I got to square it again. All right, let's do the next one. What do you get? 35. I've already factored the 2 out from the bottom, right? So I'm just squaring that number now. What do you get? 70 quarters. Again, I'm doing the arithmetic in the way I like to do it. You do arithmetic in the way you like to do it. So I'm going to say this is minus 1/2. The 0 doesn't matter to me anymore. And I'm going to factor out 70 quarters. All right, I got that covered. What do you get over here? 70 quarters minus 35. I got to keep moving through this. What are you going to go over here? Minus 35. That's because 2 goes to 35 times quarters. What do you get here? Let's put this down. It's going to be 4. You know what? Maybe I should reduce that too. Let me get my pen back out. So let me put it aside. 70 quarters is 35 halves minus 35. And that was going to be minus 35 halves then. Oh, look at that. 35 squared over 8. I'm actually going to do the arithmetic, by the way. So it's 35 squared. Let's see, 5 times 5 is 25. 5 times 3 is 15, 16, 17. That's done. 3 times 5 is 15. 3 times 3 is 9. 9 plus 1 is 10. 5, let's see, 12. Carry a 1. That's 2. So it's going to be 1225 over 8. All right. Now, I realize someone's going to say, what if I made a mistake in the arithmetic? There's plenty of opportunity to get credit in a problem like this. Plenty of opportunity. Anyway, let's look at the key and see how we did. All right. Now, someone says, what key are you talking about? The key that's being provided to you. We provide the key to you. Now, certainly it looks a little different. All right. Now, certainly, I'll tell you what I mean by that. I'm not, interchanging X and Y's, but it's really, it almost looks identical. The only difference is they're taking this region and doubling that one over there. The take-home message is this thing over here. Are we getting that for the answer? Yeah, 1225 over 8. By the way, also, I would accept 35 squared over 8 for those students who think this is too much work to do, all right? Where do most people struggle, though? Setting up the integration, by the way. And yes, arithmetic is still a struggle. Thank you.